JEE Main 2026, 2nd April Shift 2, Physics Section A, Question 42. Let's visualize the circuit. We have an LCR series circuit with an AC source V equals V0 sin 300t. A resistor R and capacitor C of 100 microfarads are in the main loop. Two parallel branches contain switch S1 with inductor L1 and switch S2 with inductor L2. When S1 is closed keeping S2 open, inductor L1 is in the circuit and the phase difference is 30 degrees. When S2 is closed keeping S1 open, inductor L2 is in the circuit and the phase difference is 60 degrees. The question states, an LCR series circuit has two switches S1 and S2. The AC source is V equals V0 sin 300t and capacitance C is 100 microfarads. When S1 is closed keeping S2 open, the phase difference is 30 degrees. When S2 is closed keeping S1 open, the phase difference is 60 degrees. We need to find 3 liters 1 minus L2. The options are A, 9 by 2, B, 2 by 9, C, 1 by 3, and D, 3. The key concept is the impedance triangle in AC circuits. In a series LCR circuit, the impedance Z has resistive component R along the horizontal and the net reactive component XL minus XC along the vertical. The phase difference phi between voltage and current is given by tan phi equals XL minus XC divided by R. The inductive reactance XL is omega times L, and the capacitive reactance XC is 1 over omega C. These relationships are the foundation for solving this problem. Step 1. First, let us find the capacitive reactance. Omega is 300 radians per second, and C is 100 microfarads, which is 10 to the power minus 4 farads. XC equals 1 over omega C. Substituting, we get 1 over 300 times 10 to the minus 4. Computing this, XC equals 100 by 3 ohms. Step 2. Set up the phase equations for each case. In case 1, S1 is closed so L1 is in the circuit. Tan 30 degrees equals XL1 minus XC over R, that gives us 1 over root 3 equals 300 liters 1 minus 100 by 3, all divided by R. This is equation 1. In case 2, S2 is closed so L2 is in the circuit. Tan 60 degrees equals XL2 minus XC over R, that gives us root 3 equals 300 liters to minus 100 by 3, all divided by R. This is equation 2. Step 3. Divide equation 2 by equation 1 to eliminate R. Root 3 divided by 1 over root 3 gives us 3. So 3 equals 300 liters to minus 100 by 3, divided by 300 liters 1 minus 100 by 3. Cross multiplying, 3 times the quantity 300 liters 1 minus 100 by 3 equals 300 liters to minus 100 by 3. Expanding, 900 liters 1 minus 100 equals 300 liters to minus 100 by 3. Rearranging, 900 liters 1 minus 300 liters to equals 200 by 3. Factoring out 300, we get 300 times the quantity 3 liters 1 minus L2 equals 200 by 3. Therefore, 3 liters 1 minus L2 equals 200 over 900, which simplifies to 2 by 9. The value of 3 liters 1 minus L2 is 2 by 9. The correct answer is option B. Here are some exam tips for AC circuits. Remember the phase angle formula, tan phi equals XL minus XC over R. The inductive reactance is omega L, and capacitive reactance is 1 over omega C. The total impedance is the square root of R squared plus XL minus XC whole squared. A useful trick, when two cases share the same R and C, divide the tangent equations to eliminate R and directly relate the inductance. Like and subscribe for more JEE Main solutions at MAGPIEHUB.